Okay, we'll look at another question on momentum, and this time we are looking at a question that has a graph. Okay, so the graph below shows how the momentum of car A changes with time just before and after the head-on collision with car B. Okay, so that graph is for car A. Car A has a mass of 1500 kg, while car B has a mass of 900 kg. Car B was traveling at a constant velocity of 15 meters per second west just before the collision. And we are told to take east as positive and consider the system as isolated. Okay, and then question number 7.1. The question is, what do you understand by the term isolated system in physics? Okay, an isolated system is a system on which the net external force is 0. Okay, 7.2. Calculate the magnitude of the velocity of car A just before the collision. That's 7.2.1. Okay, so what do we know about car A before collision? We know the momentum, which is 30,000 kg meters per second, and we know the mass of car A as 1500 kg. So here we can just use the momentum formula. Say P is equal to mv, and P is 30,000 is equal to 1500, multiply that by V. Then we divide by the 1500 both sides, and then V for car A before collision is going to be 30,000 by 1500, which is 20 meters per second. And then question number 7.2.2, calculate the velocity of car B just after the collision. Okay, so that's after the collision. So here we can use the law of conservation of linear momentum, because we know that we have car A moving east, car B west, they collide head on. So we want to know the velocity of car B after collision. So we'll use the sum of momentum before is equal to the sum of momentum after. Sum of momentum before, we have car A and car B as separate entities. So it's M1 VI of car A, that is 1, plus M2 VI of car 2 is equal to M1 VF of car 1, M2 VF of car 2. So we're looking for a VF of car 2. Okay, for M1 V1, which is car A, we already know that that momentum is 30,000. So we're just going to substitute 30,000 plus M2 now, that's the mass of car B, which is the 900 kg. 900 kg. And we're told that it's moving at 15 meters per second west, and we take east as positive. So it's going to be negative 15 is equal to the mass of car A, so the momentum of car A, that is the final momentum of car A, we already know that is 14,000 kg meters per second. So that is 14,000 kg meters per second multiplied by mass of car B, that's 900, times the VF of car B. Okay, We put that on the calculator. We will have 30,900 times -15, and that will be 16,500. 16,500 is equal to 14,000 plus 900 VF2. So 15,500 minus 14,000, that will give us 2,500 is equal to 900 VF2. Okay, now we're just going to divide by 900 both sides. 900, therefore VF2, that is the final velocity of car B after the collision, should give us 2.78 meters per second. Because it's positive, we chose east as positive, so that will be east. Okay, then the last question, question number 7.2.3. Calculate the magnitude of the net average force acting on car A during the collision. Okay, so the net force will be what? We'll say F net is equal to the rate of change in momentum. Okay, and the change in momentum for car A is what? The 14,000, which is the final momentum, minus the initial momentum. So the change in momentum here, change in P, will be 14,000 minus 30,000, which will give us 16,000, negative 16,000. That's negative 16,000 kg meters per second. Then now we're just going to substitute that into this formula. F net is equal to negative 16,000 divided by the change in time. That one is given as what? The change in time is given as 0.1 second. Okay, so that one is given as 0.1 seconds. Where do we get that? It's because we know that this part, that's the contact time. So it's 20.2 minus 20.1. That gives us the change in time or the contact time. So that will be 0.1 seconds. Now if you divide negative 16,000 by 0.1, you get negative 160,000 newtons, which is 160,000 newtons in the opposite direction. So therefore, the magnitude of the net force, F net, is equal to 160,000 newton. Keep in mind that here we are asked to calculate the magnitude, so we don't really need to specify the direction. So that's the end of that question.